4.7 and 4.8 from the pre-cal 2 book, which is Math 2412. Okay, now these are the main objectives that I'll be covering today. Evaluating inverse trigonometric functions, evaluating a composition of inverse trigonometric functions, solving a right triangle, and applications and models. Okay, now if you can recall, guys, from last week, this is when you have y equals to sine of x, right? This is my graph. Okay, and this is my domain and my range. My domain for 2 periods, right? This is 1 period. If you recall from last week, from 0 to 2 pi is 1 period, and from negative 2 pi to 0 is another period. So this is for 2 periods, and the range is from negative 1 to 1. Okay, now if you can recall, with inverse functions must be 1 to 1. In other words, one of the main characteristics is that it has to pass the horizontal line test. So if you notice, say that I put here like an imaginary line all the way across, right? It's going to hit the graph at more than 1 point, which means it doesn't have an inverse. But if I can adjust the domain to have an inverse, we can do that. Okay, but remember, guys, on inverse functions from Math 1314, that say you have the sine of x, right? The inverse, for the domain and the domain and the range is going to be reversed. For example, the domain of the sine of x is negative 2 pi over 2 pi, and the range will be negative 1 to 1. So the range of the sine becomes the domain of the arcsine. Okay, and you see there it is, right? And then now, for this to be, for this to be have an inverse, we have to adjust the range, which will be from negative pi over 2 to pi over 2. You see this way, from negative pi over 2 to pi over 2, it doesn't cross the graph at more than 1 point. So this is my range, from negative pi over 2 to pi over 2, and this is the graph. You see, if you notice, everything switches around. The domain, the range on the sine function became your domain on the inverse. Since we adjusted the range here, so now the domain for the range for the inverse becomes from negative pi over 2 to pi over 2. Now it doesn't happen the same thing with a cosine. But with a cosine, right? Again, if you notice, this is the sine wave of the cosine. If you draw like an invisible line throughout the graph, it's gonna cut at more than 1 point. So we have to adjust it. But before that, right, the domain is from negative 2 to 2 pi, right? This is 2 periods, and the range is also from negative 1 to 1, because that's my y value. Now for the arc cosine or the inverse, again, it has to be 1 to 1, and it has a characteristics that it must pass the horizontal line test when I just showed you. So we have to adjust again the domain. So we always try to get something that has the 0 included. You see, guys, if we go from negative pi over 2 to pi over 2, you see it's going to cross it twice, so we cannot do that. But if we go from from 0 to pi, now it has an inverse. So again, the range of the cosine function becomes your domain, and the range, we adjusted it from 0 to pi. Okay, and there's my graph. Okay, now for the tangent, because if you notice for the tangent, right, my domain is all real numbers, except it cannot be at every pi over 2, because at every pi over 2 there's an asymptote. So it's my domain. All the x's except pi over 2 plus n pi, which means at every pi over 2, the domain does not exist. And the range is going to be our real numbers, right? Because the range is a y value, so it goes from negative infinity to positive infinity. Now, how about the inverse? Hey guys, if we draw like an invisible line, right, through the graphs, it's going to cut the point at more than 1 point. That's why we have to adjust the range. And again, right? There's the characteristics about the horizontal line test. Now to adjust it, we have to go from negative pi over 2 to pi over 2. But if you notice, at negative pi over 2 is not included, right? Because it's an asymptote. And also at pi over 2 is also an asymptote. So instead of putting a bracket, we have to put parentheses. You see? That means that every pi over 2 is not included. Hey guys, and this is a summation of what I just did right now. Right there. Okay, now, hey guys, this is what counts right here, guys. This is the main thing here, guys. Okay? The range, which you have to know. For the sine, for the arc sine is going to be from negative pi over 2 to pi over 2. And for the cosine is going to be from 0 to pi. And for the arctangent is going to be from negative pi over 2 to pi over 2, but at pi over 2 is not included, or negative pi over 2, right? I mean, that's why it has a less than and a greater than, which means it's not equal to. So how are we going to use these? Okay, here we go. Okay, here's how you use them. Those rules that we just learned. It says here, find the exact values of each expression. A, the arc sine of negative 1/2. There's a special way to read this, okay? Here's how you read it. When evaluating the inverse sine function, it helps to remember the phrase. The arc sine of x is the angle whose sine is x. Okay? Right now, I have a better way to say that in simpler words, for the students. Okay, here's our part, right? Here's how you read it. The angle whose sine equals to negative 1/2. So you have to go to a unit circle, right? It has to be between, right? Because this is the range. Remember that from the first slide that we did? And also the summation of all three inverses. So it's going to be between negative pi over 2 and pi over 2. So that's why it's important, guys, to know the unit circle, right? And the unit circle, I covered it in week 1. There it is. Because remember, guys, this is, if it goes counterclockwise, everything's positive. But if you go clockwise, right, it's going to be negative. So, hey, guys, where the 3 pi over 2 is, that'll be my negative pi over 2. That'll be negative 3 pi, negative pi over 3. This will be negative pi over 4, negative pi over 6, and that's 0. Okay, now the range between the arcsine, guys, is from negative pi over 2 to pi over 2, which is quadrants 4 and quadrant 1. Okay, now remember that the sine is the y value. So where's the sine equal to negative 1/2? You see, guys, the negative 1/2, right? The 1/2 is at pi over 6, but that one's positive. So it has to be the one down here, which is 11 pi over 6, but we have to say that it's negative pi over 6 because 11 pi over 6 is not in the interval. So we're going to say negative pi over 6 is my answer. There's your answer. Let's do another one. The sine, the arc, right? The arc sine or the sine to a negative 1, guys, is the same thing. It means the inverse. The inverse sine of square root of 3 over 2, right? Now this is how you read it. The angle whose sine equals to 3 over 2, the square root of 3 over 2. That means that it's going to be between quadrants 4 and quadrant 1. In quadrant 4, the sine's negative, so it's got to be in quadrant 1. So we go to the square root of 3 over 2. It's going to be at pi over 3. So the answer, guys, is pi over 3. Now for C part. The inverse sine of 2, if you notice, guys, it doesn't exist. Let me show you why. Because the highest value for all the y values, which is a sine, is less than 1. And 2 is not. There's no angle where the sine is equal to 2. So for that one, guys, there's no angle, guys. So the answer is none for C part. Okay? And anyway, guys, what was the domain? Wasn't it from negative 1 to 1? You see, and 2 is more than 1. That's why there's no angle such that the inverse sine of 2, there's no angle such as that. Now, just do 3 more, which is now we're going to include the cosine and the tangent. I only did one from the cosine because the cosine and the sine are very similar. And I did 2 for the tangent. That way we can get practice on other trig functions besides sine and cosine. So let's do the A part then, right? The arc cosine of square root of 2 over 2. I mean, this is how you read it. The angle whose cosine equals to square root of 2 over 2. Again, we have to go to the unit circle. Or remember, guys, it has to be between 0 and pi. So between 0 and pi, guys, for the cosine is going to be, for the arc cosine is going to be between quadrants 1 and 2. If you notice, the x value, which is a cosine in quadrant 2, is negative. Since this is positive, it has to be in quadrant 1. And the answer is right here on pi over 4. So the answer is pi over 4. Okay, now the arctangent of 0. Okay, here, guys, is where a lot of students get confused because a tangent is not visible here on the circle, right? It's only the sine and cosine. But how do we get tangent? The tangent, okay, and it's going to be between negative pi over 2, right? Because that's my range. The tangent is equal to y over x. If you notice, the only place, right, between negative pi over 2 and pi over 2, the only place they might give me a 0 will be at 0, right? Because my y is 0 and my x is 1. At any other point, it will not give you a 0, so it's got to be at 0. At 0, you see, the tangent will be y over x, which will be 0 over 1, which will give us 0. So the answer is at 0, at 0 degrees, or at 0 radian. Okay. Now let's try C. Okay, now same thing here, guys. The angle whose tangent equals to negative 1. Okay, this is what you need to know, guys. Okay, I'm going to show you that from 0 to pi over 2. What every angle for the tangent is going to be. For example, you need to know that the tangent of 0 is equal to 0. The tangent at pi over 6 is equal to square root of 3 over 3. The tangent at pi over 4 is equal to 1. The tangent at pi over 3 is equal to square root of 3. The tangent at pi over 2 is undefined. Why is undefined? Because the tangent at pi over 2 is equal to y over x, which will be 1 over 0, and 0 cannot be in the denominator. That's why it's undefined. So now, every quadrant, guys, right, has a 3 in the denominator, a 4 in the denominator, and a 6 in the denominator. So everywhere you see a 6 in the denominator with a tangent, the answer will be square root of 3 over 3. But it depends on what quadrant, if it's positive or negative. In quadrants 1 and 3, they'll be positive. In quadrants 2 and 4, they'll be negative. And why is that? Because when you have the same signs, right, the answer is positive. When you have different signs, the answer is negative. In quadrants 1 and 2, you have both signs, and quadrant 1 is positive, positive, and quadrant 3 is negative, negative. So in quadrants 1 and 3, they're both, the tangent will be positive. And in quadrants 2 and 4, the answer is going to be negative. Why? Because the signs are different. Okay, so the answer here, guys, right, we see a 1 there, right? But remember that the range is between negative pi over 2 and pi over 2. So the answer must be here at 7 pi over 4, which is the same, which is equivalent to negative pi over 4. The answer will be negative pi over 4. And this, the arctangent of negative 1 or 1 is very, you're going to see it, guys, if you take Cal 1, Cal 2, and Cal 3, and maybe some other courses, guys. That's one of the most used tangents, guys, of negative 1 and 1. So just make sure that you know these rules here, guys, for the tangent. Okay. Now here's how to use the calculator. Okay, because we're going to have to use them. Okay, from now on. So the arctangent of negative 8.45 and the arcsine at 0.2447 and the arccosine at 2. Okay, so here's you're going to enter into the calculator. Okay, so you're going to enter. You're going to put it in radian, the mode. You're going to hit the inverse tangent in your calculator, and then it's going to give you the parentheses. So all you do is enter the negative 8.45. If you do that, the answer should be approximately negative 1.45300 10. That should be your answer, guys. So let's go to practice, guys. Okay, but make sure that you're radiant and that the mode is in radiant. Now for B, right, the same thing. So you're going to enter the arc, and I believe, guys, the arc cosine and the arc sines, if you use the calculator, guys, it's going to be in blue. So you have to hit the second button and then hit the tangent for the arc tangent and so forth. It depends on what calculator you're using, but make sure that you know how to move it from radians to degrees and back and forth. So here, guys, you're going to enter the inverse sine. You can enter, right, once you do that, it's going to give you the parentheses. So all you do is enter the 0.2447 and then you close the parentheses. When you do that, the answer should be 0.2472103. That's your answer. Now for part C, right, if you enter the arc cosine of 2, well, guess what, guys, you're going to get an error message. And why is that? Because there's no such number. There's no such number that will be defined between -1 and 1. Because remember, guys, 2 is not between -1 and 1. So that's why it's undefined or it's not there. Okay. So every time that you get an error message, it means it's not part of your domain. Okay, now this is review from week 1. Why are we doing this? Because this is crucial for what's to come. Okay, so instead of just jumping in to what I need to cover for this section, I want to go back and review just one problem, guys. Okay, but we have to find the other 5 trig functions. Right? You guys should know that cosine is equal to adjacent over hypotenuse. Right? There's my triangle. Right? The adjacent is 3 and the hypotenuse is 5. So to solve the other 5 trig functions, we have to solve for the opposite side. And for that, since this is a right triangle, we use a Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, we can call 3a, right, and the opposite will be b, and the hypotenuse will be 5, so it'll be 3 squared plus b squared equals 5 squared. We get 9 plus b squared equals 25. If we subtract both sides by 9, it's going to give us 16. So b squared equals 16, so b equals to 4, right? Because we take the square root of both sides. So I know the opposite is going to be 4. Now I can find the other 5 trig functions, right? The cosine of theta is 3 over 5, right? That was given. Now the reciprocal of the cosine is going to be the secant. So since cosine is adjacent to hypotenuse, the secant will be hypotenuse over adjacent. So all we do is flip or use the reciprocal of the cosine, which will be 5 over 3. I'll do it right now. And the sine is opposite over hypotenuse. The cosecant, right, they're reciprocals of each other. The tangent is opposite over adjacent, so the cotangent will be adjacent over opposite. Now, to get the secant, all we do is do the reciprocal of the cosine, which will be 5 over 3. For the sine, right, it's opposite. It means 4 over hypotenuse, which will be 5, so it'll be 4/5. So the cosecant and the sine are opposite reciprocals. So if the sine is 4 over 5, the cosecant is 5 over 4. The tangent is opposite over adjacent, so opposite is 4, adjacent is 3. So it's going to give us 4/3. And again, the tangent and cotangent are opposite reciprocals. So if the tangent is 4/3, then my cotangent will be 3/4. Okay, guys, you have to know this stuff here for this section, also for the next section. Okay, now let's continue. This is called evaluating a composition of inverse trigonometric functions. Okay, example. It says find the exact values of each expression. Hey guys, the mistake that students make is that they want to put that in the calculator, guys, but if you put that in the calculator, guys, it's going to give you like a rational number, like irrational number. It never ends, well, which is wrong. Here they want the exact values, okay, and here's how you do it. Okay, we have the tangent of our cosine of 2/3. Hey guys, so what's in the inside, guys, right? What's in the inside, which is the arc cosine of 2/3, from there, we're going to form our right triangle. Okay? And we know this is quadrant 1. Why is it quadrant 1? Because the cosine is between 0 and pi. And the cosine is positive in quadrant 1, and the cosine is negative in quadrant 2. Right? So that's why we know it's quadrant 1. Right? So this is the signs for the sine, cosine, and tangent of quadrant 1. The sine's positive, cosine's positive, and tangent's positive. Okay, so here, everything will be positive, so the tangent will also be positive. I mean, my answer will be positive. Okay? So again, the cosine will be 2 over 3, which will be adjacent over hypotenuse. Right? Now let's go to the triangle. So the adjacent is going to be 2. The hypotenuse is going to be 3. So we're trying to find the opposite. How do we find it? By the Pythagorean theorem. So we have 2 squared plus b squared equals 3 squared. So 4 plus b squared equals 9. We subtract 4 from both sides, will give us 5. So b squared equals to 5. If we take the square root, b is equal to square root of 5. So I found my opposite. Now you're looking for the tangent. You see, guys, this here is the most important part of here. That's the most important part, because now this is only one trig function that I gotta find, which is a tangent, and that's it. But if this was cotangent, sine, cosecant, whatever it is, guys, all we do is follow follow each function what it is. For example, the tangent is opposite over adjacent. So we go to our triangle. The opposite is square root of 5, and the adjacent is 2. So this is my answer, guys. The square root of 5 over 2. Okay? Let's try another one. It says here, find the exact values of each expression. So again, from the inside, guys, we're going to form our triangle from the arcsine of negative 3/5. But the first thing we got to know is what's the quadrant. Okay, the quadrant is going to be 4. Why 4? Because the range of the inverse sine is from negative pi over 2 to pi over 2, right? Which is quadrant 4 and quadrant 1. So we know it's going to be quadrant 4. So here, guys, the sine is going to be negative, cosine positive, and tangent negative. Since here, guys, we're looking for the cosine, the answer is going to be positive. Now we can disregard the signs here. We know the answer is going to be positive. Okay. So from here, guys, we form our triangle. It's going to be opposite is 3 over adjacent. Over hypotenuse. So the opposite is going to be 3. The hypotenuse is going to be 5, the hypotenuse. So we're looking for the adjacent. And from here, guys, we're going to use the Pythagorean theorem. So it'll be a squared plus 3 squared equals 5 squared. A squared plus 9 equals 25. We subtract 9 from both sides, so it's going to give us 16. So a squared equals to 16. We take the square root of both sides. A is equal to 4. So my adjacent is 4. Okay, now what are we looking for? We're looking for the cosine. And the cosine is adjacent over hypotenuse. So my adjacent is 4. My hypotenuse is 5. So this is my result, guys. 4/5 is my answer. Okay, what happens, guys, when you have, this is number 57 from that section. When you don't have numbers, just a number and a variable. Okay, just do the same procedure. So I know, right? So I know it's going to be quadrant 1 because the sign is positive. So everything is positive in quadrant 1. So we don't have to worry about the signs no more. So now from here, guys, we're going to form our triangle. So sine will be 2x over 1. Right? So you have to put a denominator. So the opposite will be 2x, and the hypotenuse will be 1, the hypotenuse. From there, we get a triangle. Opposite is 2x. Hypotenuse is 1. So we're searching for the adjacent. Again, we use the Pythagorean theorem. So a squared plus b squared equals c squared. So we're going to plug in 2x for b. So we have a squared plus 2x squared equals to 1. That's going to give us a squared plus 4x squared equals to 1. We subtract 4x squared to both sides. So a squared equals to 1 minus 4x squared. We take the square root of both sides. So a equals to the square root of 1 minus 4x squared. That's my adjacent. Okay. Now we're looking for the cosine. The cosine is adjacent or hypotenuse. So it's going to give us the square root of 1 minus 4x squared over 1, which will give us the square root of 1 minus 4x squared. That's your result. Okay. Now, let's do one more. Find the exact values of each expression. So again, right, it's quadrant 1 because it's positive. So everything's going to be positive. So from the arc cosine, we're going to get a triangle, which will be adjacent or hypotenuse. The adjacent is going to be x, and the hypotenuse is going to be 3. So we're searching for the opposite. Again, we use the Pythagorean theorem, which will be x squared plus b squared equals 3 squared. So b squared equals to 9 minus x squared. We take the square root of both sides, so b equals to the square root of 9 minus x squared. That's my opposite. Now we're looking for the tangent. So a tangent is opposite over adjacent. So the opposite is the square root of 9 minus x squared, and the adjacent will be x. So this is my result. The square root of 9 minus x squared over x. Okay, now, hey guys, this here, the next two examples is going to lead you to the next section, which is 4.8. It says here, use an inverse trigonometric function to write theta as a function of x. So in other words, you're trying to have theta equals to something with x. Okay. So here, guys, right? So here, what we're going to do, what's given? What's given is opposite and hypotenuse, right? So then we're going to use what's opposite over hypotenuse. It's going to be opposite hypotenuse. It's going to be the sine, right? The sine of opposite over hypotenuse. So we're going to use the sine. Sine of theta equals to opposite over hypotenuse. So the opposite will be x plus 2, and hypotenuse will be 5. Okay? So it gives us the sine of theta equals to x plus 2 over 5. Okay, now, how do we cancel the sine just to give me theta? Here's where the inverse comes into play. Okay? I'm going to put the inverse of sine on the left side, and also the inverse of sine on the right side, but I'm going to put it on the left side of x plus 2 over 5. Okay? Now, these guys cancel. This is equal to 1, because the inverse and the sine, or the inverse and anything will always cancel. I mean, they don't cancel, but it's equal to 1. So on the left side, we're going to have theta equals to the inverse sine of x plus 2 over 5. So this is the answer for A part. I mean that's the answer that they want. Okay. Now here's how we use it in real life. This is number 93 from the same section, which is 9.7. I mean 4.7. It says a boat is pulled in by means of winch located on a deck 5 feet above the deck of the boat. See the figure, which is this figure below here. Let theta be the angle of elevation from the boat to the winch, and the length of the rope from the winch to the boat. Okay? So here, guys, here's my solution. I'm going to get what's given and form a triangle, right? So I'm going to get this here, guys, the given information, and form a triangle. See, there it is, guys. There's my 5, right? Which is the opposite. There's my angle, and there's my S. So for A part, they want us to do what we just did on the previous slide. We were number 57, right? So I need to solve for theta. So what's given again, the opposite of hypotenuse. So we're going to use the same thing. We're going to use the sine, because sine is opposite of hypotenuse. So the sine of theta equals to 5 over S. Now, how do we solve for sine again, right? We're going to take the arc sine, but for now, guys, you guys should know that we can go from here to here. In the past, I didn't know how instructors went. I mean, when I was a student, I didn't know how instructors went from this step to the theta by itself. And then actually, when I asked, and they told me, yeah, because you take the arc sine, the inverse of both sides. So from now on, guys, I'm not going to put what I did in the previous slide, where you put the arc sine on both sides. No, we just go from here, from this step to the answer. So this is my answer, guys, for A part. Theta is equal to the arc sine of 5 over S. Now let's do B part. When S is 40, all we do is, right, get the formula. We're going to plug in 40 for the S is in part A. But I believe here, guys, they want the answer in radian, but I also put the degrees. The answer in the book, I believe it was in radian. But this is the answer in degrees, and that's in radians. Okay, which is 7.18 degrees or 0.13 radian. Now for the second part of B, when S equals to 20, we repeat the procedure, but instead of putting 40, we're going to plug in 20 where the S is. And our answer should be something like 14.47 degrees or 0.25 radian. Check this out, guys, right? I mean, check this out. This is kind of interesting. Right, if you notice, if S is 40, right, if the length of the rope is 40, you get 7.18 or 0.13. But when it's 20, right, when it was cut in half, the degrees and the radian, they doubled. Isn't that kind of weird? Right? But that's mathematics for you. You see, it went from 7.18 to 14.47. It went from 0.13 radian to 0.25 radian. Okay, so that's how you do also proportions. Okay, now this is the first problem from 4.8. They want you to solve a right triangle. Okay, let's do it then, right? Let's see what they give us. By solve, you have to find angle A, angle B, angle C, little a, little b, little c. As you notice, angle A, right? The angle A, the little a is a side across from angle A or opposite from angle A. And little b is the length or the side opposite from the angle B. And same thing with the C, guys. So we have to solve A, B, C, right? The angles and the sides. Let's enter what they give us, right? They give us angle A is 34.2. They give us little b is 19.4. But we should know that a right triangle, right angle C is 90 degrees. Okay? So we're looking for angle B, side A, and side C. Let's first find angle B. Why? Because I believe it's easier, right? Because all the angles, the measure of all the degrees inside a triangle has to equal to 180 degrees. So angle A plus angle B plus angle C must equal to 180. Okay, so we're looking for angle B. Angle B is equal to 180 minus angle A minus angle C. Now let's plug everything in. It'll be 180 minus 34.2 minus 90 degrees is going to give us 86.8 degrees. So this is the answer for angle B. Okay? Okay, now let's do this. Now, how do we solve for little a? Okay, let's see what's given us. Angle and adjacent are right. The angle and adjacent are given. So we need to use the trig functions with adjacent. Right? We cannot use sine because the sine doesn't have adjacent. We have to use cosine, we have to use tangent. Okay? So let's see, guys. To find A, right? So to find A, it's going to be the tangent because the tangent is opposite over adjacent. So we have to use a tangent. So tangent of 34.2 degrees is equal to A over 19.4. So to solve for A, guys, we multiply both sides by 19.4 and just use your calculator, guys, and make sure that your radian is, that your most in degrees, you get something like 13.2. Approximately, right? Because I believe they want you to round off to one place. So little a or length A is 13.2. Now to find C, right? To find C, we have to use, right, the tangent. We have to use the cosine because cosine is adjacent over hypotenuse. So we have to use the cosine. So cosine of 34.2 equals to 19.4 divided by C. And guys, here, guys, you can switch the C and the cosine of 34.2 degrees by using proportions. Now just put that in your calculator. You're going to get something like approximately 23.5. So the length of C is 23.5. That's how you solve a right triangle. Okay, now let's do another one. Again, right, we have to solve it. So let's see what they give us. They give us angle B. We know what angle C is. Angle C is 90 degrees. And they give us little a, which is 4.4. Okay, so again, let's do the same thing as what we did before to solve for angle A. It's going to be A equals to 180 minus B minus C. Let's plug in the values. So we're going to get something like 17.2. So A is 17.2 degrees. Okay, now, they give us the angle and the adjacent right the angle, which is angle A. And we're using, let me check this out, guys, with the original information, right? We can use this angle here. We can use angle B, right? Angle B was given. And also the adjacent. So the angle adjacent are given. So you need to use a trig function with something with adjacent, right? That's angle B, and that's little a. So again, to find B, we can use opposite, right, over adjacent, which will be tangent. Just plug in the values. And again, guys, here we're going to multiply both sides by 4.4. So B equals to 4.4 times tangent of 72.8 degrees. The answer will be approximately 14.21. That's little b. Now to find little c, right? To find little c is going to be, let's see, adjacent, opposite, no, let's see, it's going to be cosine, right? Cosine is going to be adjacent over hypotenuse. So it's going to be the cosine again. Plug in all the values. Again, here we crisscross. The c goes to the left, and the cosine 72.8 goes on the denominator. And we use the calculator, and we're going to get approximately 14.88. That's little c. Okay, now, let's do one more, guys, but this is a little bit different now. Because on this one, they didn't give you an extra angle. They just gave you the length, the sides of A and B. So we know that, right, so two sides are given. We can find C by using the Pythagorean theorem. So we can find little c by using the Pythagorean theorem. My A is 3, my B is 4, and my C is 90 degrees, the angle. So let's first solve for side C, right? So 3 squared plus 4 squared equals C squared. 25 equals C squared. So C equals to the square root of 25. C equals to 5. So I found little c. Now I need to find angle A and angle B. How can we find angle A? Because here, guys, you can use any trig function that you want to use, right? I just brought this angle down and I have all the given information, right? The A is 3, the B is 4, and the C is 5, and the angle is 90 degrees. So to find, right, you can use any angle. You can use B or you can use A. If I use A, guys, right, I can use opposite over adjacent, which is a tangent. I can use adjacent over opposite, which is adjacent over hypotenuse, which is a cosine, or opposite over hypotenuse, which is a sine. You can use any angle here, guys, okay? But here I'm going to choose the sine. So I'm going to use opposite, which is 3 over 5. Now, how do we cancel the sine, guys? Again, remember how to cancel the sine, so we take the arcsine on both sides. So the angle A is equal to the arcsine of 3 over 5. Now put that into the calculator. Make sure it's in degrees. You're going to get something like 36.87. So that's my angle A. Now to solve for angle B, right? We use A plus angle B plus angle C equals to 180. So angle B equals to 180 minus angle A minus angle C. So it'll be 180 minus 36.87 minus 90 degrees. It's going to give us approximately 53.13. So the angle B is 53.13. I believe here, guys, this is from the homework number 9. I believe they want you to round off to 2 places. So this is how you solve the right triangle when they give you only the right triangle, which is angle C, but they didn't give you angle A or B. You have to use the inverse. That's why it's crucial to know how to use it. Okay, now, this is number 17 from the book, again, from the homework. It says the sun is 25 degrees above the horizon. Find the length of a shadow cast by a building that is 100 feet tall. See the figure. Okay. So in other words, guys, there's your sun, there's your angle, and you're looking for this out here, guys. This is a shadow that it creates. Okay. Solution, we are given an angle and the opposite, and we're looking for the adjacent. So from the trig functions, which one has opposite or adjacent? It's going to be my tangent, right? The tangent has opposite or adjacent, so it's going to be the tangent of 25 degrees equals to 100 over x. Again, remember, guys, we switch x in the tangent by using proportions. We use the calculator. So it's going to give us approximately 214.45 feet. That's the length of that shadow. And again, I believe in the homework, I want you to round off to 2 places. Okay? This is number 19. Hey guys, here, guys, let me go back. Here, they want you to draw your own triangle. Okay? It says a ladder that is 20 feet long leans against the side of a house. The angle of elevation of the ladder is 80 degrees. Find the height from the top of the ladder to the ground. Okay, so here's my drawing. Guys, there's like the building, right, or the house. There's my ladder. The ladder is 20 feet, correct? And the angle, right, this angle here of elevation is 80 degrees. So we're looking from the height of the height of the ladder to the bottom. So we're looking for this length here on the side of the house. Okay. So we're looking for the x. Now, what's given? What's given is the angle and hypotenuse, right? And we're looking for the opposite. So, right, so we're going to use opposite or hypotenuse. So we're going to use the sine, right? Because the sine of 80 degrees equals to the opposite over hypotenuse. Okay, here we go. So again, here, guys, so we multiply both sides by 20. So x equals 20 times sine of 80 will give us approximately 19.696 feet, which would be something like 19.7 feet. So the height of the ladder to the ground is 19.7 feet. Okay. Now I believe this is the last one, and I also believe this is the hardest one of all. Okay. I remember having a hard time, guys, when I was a student back in like 2006. This is the same problem, guys, that they had back then. But I used to have a hard time with this one. But it is not that complicated. Okay, I'm going to break it down for you guys. It says here, an observer in a lighthouse 350 feet above sea level observes 2 ships directly offshore. The angles of depression to the ships are 4 degrees and 6.5 degrees. See the figure. How far apart are the ships, right? So let's call it ship 1 and ship 2, right? So for the solution, guys, I'm going to form 2 triangles. Okay? Right, this is my first triangle, right? Because that's 350, this also has to be 350. So get this triangle and put it down here. Okay? This is 350. The theta is going to be 6.5. And this here, guys, this is right, because this distance is the same as this one up here. So we're looking let's call this D1. Now let's repeat the process for the next chip, right? So again, so I'm going to take again, right? I'm going to take this triangle and put it down here, right? So this is 350, right? Because same thing as over here is 350 feet. The angle is 4 degrees. And this distance from the lighthouse to the chip number 2 will give you is D2. Okay? So now we have to find this, we have to find distance 1 and distance 2. And then after, right, to find this distance, how far they're apart, we subtract D2 from D1. Okay? Again, we are looking for a given angle. Right, we're looking for the given angle. I mean, we're given a given, right? This is given, and also the opposite is given. And we're looking for the adjacent, right? So we have to use the tangent because tangent is opposite or adjacent. So it's going to be the tangent of 6.5 equals to 350 over D1. Right? So again, right, we use a proportion. So D1 equals to 350 over tangent of 6.5. So the distance 1 is equal like 3,071.91 feet. Okay. Now we repeat the process for the distance 2, which would be tangent of 4 degrees is equal to opposite 350 over distance 2. Right? We use proportions. So D2 equals to 350 over tangent of 4. Again, we use a calculator, and it's going to give us something like 5,500.23 feet. Okay? Okay, now, this is a part, right? D3 is equal to D2 minus D1, guys. This here, guys, on the sketch is D3. Right? So D3 is equal to D2 minus D1. Here we go. So D2 is 5,005.23 feet, and D1 was 3,071.91 feet. We subtract, it's going to give us something like 1,133.3 feet. So the two shapes are 1,133.3 feet apart. Because that's how you use trigonometry, guys, with angles and right angles and right triangles in the real life. And I believe that's it for my PowerPoint, guys. I just finished on time. Let me take it back to the host, and if you have any questions, please let me know.
Thank you very much, Mr. Isasi, for your wonderful presentation. We do want to remind you all about our previously recorded session, which are available on the YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions, so please take time to fill out the survey. Before you leave, I want to share the TVE sessions that we will have next week. Next week, we will be back with Happy Math Hour, in which our Math 1332 will be covering logic statements, truth tables, conditional and biconditional statements. Math 2412 will be covering exam review number 1. Today at 1, hopefully you could join us and be back, and we will have the student success topic. Today's topic will be Dr. Servin. He will be covering the hack. He will be presenting the hack the border overview and purpose. So thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. Have a great weekend, everybody.